And similarly, you can also force position this vector B in such a way, and you put the vector A so that the initial point of this vector A coincides with the terminal point of this vector B. Then the vector which has the initial point of this vector B as the initial point, and the terminal point of this vector A as the terminal point, is the sum of this B and A, so that you get the B plus A. And in the first way, you get A plus B. And both of these two guys just stand for the same vector, the sum of the vector A and the vector B. So this is how we add two vectors. But we have some special case. So if you have the two vectors which have the same direction, then in this case you cannot form a parallelogram, right? But you can use the second way to get the sum of these two vectors. For example, we have the vectors A here and the vector B here. And if you want to add these two vectors, in this case, since they have the same direction, you cannot form a parallelogram. You may just position this vector B so that the initial point of this vector B coincides with the terminal point of the vector A. So here this vector A, and then followed by the vector B. Then this guy is the vector A plus vector B. And another special case is we have the two vectors which have the opposite directions. So we have the vector A like this. So this is vector A. And then we have the vector B like this. Now, you still position this vector A or this vector B so that the initial point coincides with the terminal point of the vector A. Let me use the color. So right now, here. And then you have the vector B and here, right? So now, what is the A plus B? The A plus B is just this vector. Let me use the color. So this guy. This is the vector A plus vector B. Okay, so these are the two special cases in which we cannot form a parallelogram, but we can still use the second method by positioning one vector so that the initial point of this vector coincides with the terminal point of the other vector. Any question? So right now we know how to add the two vectors, and let's see how we subtract the two vectors. So to define vector A minus vector B, we may first begin with the special scalar multiplication. So we let the k equal to -1, and then we know k times A is just equal to -8, which is the opposite of vector A, right? And then vector A plus negative vector A, this guy is just equal to 0 vector. You see, if you let this vector be equal to negative vector A, then A plus the negative A is equal to 0 vector. So generally, if you want to subtract one vector from another vector, you may define this subtraction in the way, okay, in the form of the addition. So this is defined as the vector A plus negative vector B. And let's go to the fig. So now this is my vector A and this is my vector B. Now I want to get the A minus B, so first I get the opposite of the vector B, so that is a negative B. And then I use the A and the negative B to form a parallelogram. Then A plus negative B, that should be, okay, indicated by this diagonal of this parallelogram. So this is A minus B. And you can also connect the terminal points of this vector A and vector B in such a way. And now you see this red vector is just same as the A minus B, right? Because they have the same length and same direction. So this just tells us another way to get the difference of two vectors. You want to get the A minus B, then you use the terminal point of the vector B as the initial point of the difference, and the terminal point of the vector A as the terminal point of this difference, and then you get this A minus B. Okay, this is the subtraction of two vectors. Now let's talk about the horizontal and the vertical components of a vector. So given a vector W, this vector W, okay, can always be written as the sum of a vertical component and a horizontal component, like this. And this is my W. I use the W sub x for the horizontal component, and I use the W sub y for the vertical component of this W. So Wx, this is the horizontal component of vector W, and Wy, this is vertical component of the vector W. And in this rectangle, we know a rectangle is also a parallelogram, right? It's a special case of the parallelogram. So by the parallelogram law, this W is just equal to this w sub x plus w sub y. So this is how we rewrite a vector as the sum of its horizontal and vertical components. Now, let's position this vector into a rectangular plane with the initial point of this vector at the origin.